Great question. And the answer to that, she asked, well, have we even solved a differential equation? And the answer is no. We haven't found y yet. We haven't. And that brings me a few thoughts. One, we're going to find y now because this equation can be solved. And so we're going to do it a couple different times. A lot of differential equations cannot be solved. However, the behavior of the differential equation can be understood. So even though in this example, even though we haven't solved it, we know what the solution looks like. And we know what the behavior will be expected. And we know that without even having to solve the equation. So when you go on in differential equations, oftentimes the answer of just trying to get a y isn't the real part of the problem. The part of the problem is, can you understand it without even getting a y? Do you know what to expect? So a lot of differential equations problems you'll find you doing that. And then also, like, regarding how I'm going to ask this information on the test, some of his questions I think get too hard too fast. So if you're not sure what to do and how to study for this section, I have some homework. You'll do those problems. And then I would just review this section. Like, good questions would be like, for you to be able to construct those two graphs with y and y prime, and then t and y, and be able to show, find the steady states. Those would all be questions that would be good for a test. What's the carrying capacity given a logistic equation? Okay. So let's start. Let's solve. Let's solve. Okay. We're going to solve 1, 2, maybe even 3 answers. Here's how it goes. Let's start with our very first problem. Let's solve our first problem. That was without particles. So, solve y prime equals 4y minus y squared. So this has a pattern, and then the pattern is one of your homework problems. But this problem where you have y, and then you have y to some power. This is called a Bernoulli differential equation. And I've solved it for you once. We're going to solve it for you again because I don't think it's easy the first time you see it. And the solution is always this. If this is to the second power, then you make a substitution, and we called it z. And the substitution is always 1 over y to the whatever that number is, minus 1. So we're going to let z be 1 over y. You guys remember this? If you don't, that's okay. That's the first time I'm going to show you. It's a pretty clever solution. So what we're going to do is we take the derivative of y with respect to t. So we're going to take dz dt. Derivative of z. So remember, z is a function of y. So I'd say, well, that's the derivative of z with respect to y. But wait a minute. We want to take the derivative with respect to t. But y is a function of t, so we apply the chain rule and we say this is the derivative of y with respect to t. Holy smokes, what do we do with that? Oh, I know. We take the derivative of z with respect to y. That's going to be minus 1 over y squared. Times, what's the derivative of y with respect to t, though? The answer is only 4. It's right there. That's the derivative of y with respect to t. So times 4y minus y squared. Isn't that the slickest thing? Yes?
Can you just take a step back and just re-explain rate secant over the 1 over y?
Oh, it's a pattern.
Over y.
It's a pattern. I'm just going to tell you that we can use this pattern to solve it, and the pattern is whenever you have y and then y to some power, you can solve, like this could be to the 10th power, and what you do is you put this in here, and you subtract 1, and that's the substitution that we're going to use. And it's called a Bernoulli. I think it's like that. Bernoulli. I know, that's what I was just sitting here trying to remember. Is it 2? Okay. Let's give him 2. A Bernoulli differential equation. There's a whole bunch of Bernoullis. Like for a couple, like 100 years of Bernoulli. So when you say Bernoulli, there's like the first one, and there's sons and families. So I don't know which Bernoulli figured this out. I just don't. Okay, let's continue on. If I distribute this, I'm going to come up with a minus 4 times 1 over y. Is that correct? I hope so. Plus 1. That worked? It did. But what is 1 over y? That's z. So we can solve this as, come over here. So now we have z is, what did I just say, minus 4 times z plus 1. That should look familiar. Does that look familiar? No. Yes, right?
Is that supposed to be C prime?
Oh yeah, C prime. C prime. Okay. And this we can solve just by an integrating factor. I don't have the formula memorized. I wish I did right now. Z prime plus 4z is equal to 1. So we take the derivative with respect to t of e4t times z is equal to 1 times e4t. Let's use an integrating factor. Take the integral of both sides. So from z of 0 t, and from 0 to t. Oh man, you know, that was too fast. I made mistakes. I'll just write a new one. It's the integral from z of 0 to z of t. Derivative with respect to t, e to the 4 t, I'll write it z of t, dt is equal to the integral 0 to t of e 4t. Let's see, I think we got one more line here. You can write this as e to the 4t z of t minus z of 0 is equal to 1/4 times, oh, this could have been in S's, sorry. So we're going to have e to the 4t minus 1. Let's do this in 2 steps here. Right? Let's add z of 0, and then we have to distribute an e to the minus 4t through the entire equation. So let's do that. Let's write this as z prime, or I'm sorry, z of t is equal to z of 0 e to the minus 4t plus, let's distribute all of this through. We have 1 plus 1/4. 1/4. This is going to give 1 minus e to the minus 4t. There, I think we got that. I'm going to combine some like terms. I have an e to the minus 4t times z of 0 minus a 4 plus. Did I do that right? Okay. And, oh, we wanted y. I know. So, but remember, if z is 1 over y, y is 1 over z. So, oh man, this gets good. Watch this. So it becomes y of t is equal to 1 over this piece. So let's go through this carefully. I have e to the minus 4t times, oh wait, but z of 0, we have to change it. It becomes, z of 0 is 1 over oh, yes, let's go on here. Y of 0. See, if I have y is 1 over z. Did I do that right? I don't remember. Y of 0 is 1 over z of 0, or you can say that z of 0 is 1 over y of 0. Ah, okay, there it is. 1 over y of 0 minus a 4 plus a 4. And we're down to a good looking solution. Questions on that? Let's solve one more. So our last one we're going to do is solve y prime equals, I'm just going to write this again, 4y minus y squared plus, go into 1. if I have a